This video is titled, What is a Neural Network? It includes topics on artificial intelligence, machine learning, deep learning, and neural networks. Just a disclaimer, the content provided is property of IBM and Amazon Web Services. No original thought of my own is provided in this video. The purpose of this video is for me and others to have a quick refresher of these concepts. All the information was pulled from 2 IBM articles as well as 1 AWS article. The links are below. What is a neural network? A neural network is a method in artificial intelligence that teaches computers to process data in a way that is inspired by the human brain. It is a type of machine learning called deep learning that uses interconnected nodes or neurons in a layered structure that resembles a human brain. It creates an adaptive system that computers use to learn from their mistakes and improve continuously. Thus, artificial neural networks attempt to solve complicated problems like summarizing documents or recognizing faces with greater accuracy. Every neural network consists of layers of nodes or artificial neurons, an input layer, one or more hidden layers, and an output layer. Each node connects to others and has its own associated weight and threshold. If the output of any individual node is above the specified threshold value, that node is activated, sending data to the next layer of the network. Otherwise, no data is passed along to the next layer of the network. Neural networks rely on training data to learn and improve their accuracy over time. Once they are fine-tuned for accuracy, they are powerful tools in computer science and artificial intelligence, allowing us to classify and cluster data at a high velocity. Task and speech recognition or image recognition can take minutes versus hours when compared to the manual identification provided by human experts. One of the best known examples of a neural network is Google's search algorithm. Most deep neural networks are feed-forward, meaning they flow in one direction only, from input to output. However, you can also train your model through back propagation, that is, move in the opposite direction from output to input. Back propagation allows us to calculate and attribute the error associated with each neuron, allowing us to adjust and fit the parameters of the modes appropriately. Convolutional neural networks are similar to feed-forward networks, but they're usually utilized for image recognition, pattern recognition, and/or computer vision. These networks harness principles from linear algebra, particularly matrix multiplication, to identify patterns with an image. Recurrent neural networks are identified by their feedback loops. These learning algorithms are primarily leveraged when using time series data to make predictions about future outcomes, such as stock market predictions or sales forecasting. Deep learning and neural networks tend to be used interchangeably in conversation, which can be confusing. As a result, it's worth noting that the deep and deep learning is just referring to the depth of layers in a neural network. A neural network that consists of more than 3 layers, which would be inclusive of the inputs and the output, can be considered a deep learning algorithm. A neural network that only has 2 or 3 layers is just a basic neural network. Here's a graphic of a deep neural network. As you can see on the left, there's an input layer. Then in the middle, there are multiple hidden layers. And then on the right, that ultimately leads to an output layer. How do AI, machine learning, deep learning, and neural networks relate to each other? The easiest way to think about AI, machine learning, deep learning, and neural networks is to think of them as a series of AI systems from largest to smallest, each encompassing the next. AI is an overarching system, machine learning is a subset of AI, deep learning is a subfield of machine learning, and neural networks make up the backbone of deep learning algorithms. It's the number of node layers or depth of neural networks that distinguishes a single neural network from a deep learning algorithm, which must have more than 3. What is AI? The 3 main categories of AI are artificial narrow intelligence, ANI, artificial general intelligence, AGI, and artificial superintelligence, ASI. ANI is considered weak AI, whereas the two other types are classified as strong AI. We define weak AI by its ability to complete a specific task, like winning a chess game or identifying a particular individual in a series of photos. Natural language processing and computer vision, which let companies automate tasks and underpin chatbots and virtual assistants, such as Siri and Alexa, are examples of A&I. Computer vision is a factor in the development of self-driving cars. Stronger forms of AI like AGI and ASI incorporate human behaviors more prominently, such as the ability to interpret tone and emotion. Strong AI is defined by its ability compared to humans. AGI would perform on par with another human, while ASI, also known as superintelligence, would surpass a human's intelligence and ability. Neither form of strong AI exists yet, but research in this field is ongoing. What is machine learning? Machine learning is a subset of AI that allows for optimization. When set up correctly, it helps you make predictions that minimize the errors that arise from merely guessing. For example, companies like Amazon use machine learning to recommend products to a specific customer based on what they've looked at and bought before. For example, let's say I showed you a series of images of different types of fast food, pizza, burger, or taco. A human expert working on those images would determine the characteristics distinguishing each picture as a specific fast food type. The bread in each food type might be a distinguishing feature. Alternatively, they might use labels such as pizza, burger, or taco to streamline the learning process through supervised learning. How deep learning differs from machine learning. Observing patterns in the data allows a deep learning model to cluster inputs appropriately. Taking the same example from earlier, we might group pictures of pizzas, burgers, and tacos into their respective categories based on the similarities or differences identified in the images. A deep learning model requires more data points to improve accuracy, whereas a machine learning model relies on less given data given its underlying data structure. Enterprises generally use deep learning for more complex tasks like virtual assistants or fraud detection. Most deep neural networks are feed-forward, meaning they only flow in one direction from input to output. However, you can also train your model through backpropagation, meaning moving in the opposite direction from output to input. Backpropagation allows us to calculate and attribute the error that is associated with each neuron, allowing us to adjust and fit the algorithm appropriately. That comes to the end of the video. Thanks for watching and listening, and I hope you enjoyed it. Have a great day.